Okay, today's lesson is on the conservation of energy. So the idea is that the total energy in the system will remain constant. Energy can neither be created nor destroyed. So basically, if you have some energy at the beginning of the story, you're going to have the same amount of energy at the end of the story, even if you change the form of energy it's in, right? So the total energy is the sum of all the energies, right? So you have your kinetic energy, your gravitational energy, your spring energy, your dissipated energy, all your whatever other kinds of energy. The total energy is all the energies added up. Pretty straightforward. Okay, so the steps from last time are pretty much the same as the steps from this time, except when you do your equation is often going to be E initial equals E final. Remember the O, as in like V naught and whatever, X naught. The E naught means initial energy, and then obviously the final energy. Okay? So then you're going to plug all your known values, solve for your unknown. There should only be one unknown. So you got to remember to do this every time. Okay, these are the steps. If this was a quiz or whatever, you get docked points if you didn't follow all of these steps. Okay? So conservation of energy specifically, the initial energy equals the final energy. So the first thing you decide is what type of energy at the beginning of the story and the end of the story. And then put the equations for the types of energies equal to each other, plug in what you know, solve for what you don't. So for example, if I take a baseball and I put it into a slingshot, when I pull the slingshot back, start of the story, I have elastic energy or spring energy. When I let go of the slingshot and launch the baseball, then the baseball has kinetic energy because it's moving. So you have to ask yourself the question, is it high? Is it fast? Is it moving? And then if it's one of those things, then that's kind of energy it has. So, 5 kilogram bowling ball, 2 meters above the ground, is dropped. How fast will it be traveling the instant before it hits the ground? So the first question we have is, what are our knowns and unknowns? We know its mass is 5, we know its height is 2, we're looking for the velocity at the end of the story. So here's the ball, that ball falls, or whatever. What's going to be velocity right when it hits the ground? So, at the beginning of the story, is it high? Yes. Is it fast? No, not the beginning. Is it springy? No. When it lands, is it high? No. Is it fast? Yes. Is it springy? No. So then at the beginning of the story, our initial energy is going to be just gravitational. And our ending energy is going to be kinetic. Since at the beginning of the story it's high, and at the end of the story it's fast. Right? So then Eg we know is mgh. And Ek we know is 1/2 mv squared. So then we plug in m is 5, g is 10, h is 2, 1/2 is 1/2, m is 5, v squared is still v squared. So we can simplify this down, and we end up that our velocity at the end of the story is 6.3 meters per second. Okay, so again, start out with EO equals EF. Then I ask, what is the energy at the beginning of the story? Is it high? Yes. Is it fast? No. Is it springy? No. At the end of the story, is it high? No. Is it fast? Yes. Is it springy? No. So it's EG equals EK. Okay. You have a pendulum. The center of the ball is at a height of this, above the lowest point of the ball's path. First, let's find the ball's potential energy at this height. Okay, so first of all, now we're just finding the total energy, the potential energy at this height. So what kind of an equation is that? Okay, well, for the first half, we're just looking at m is 1.8, h is 0.75, e is our question mark. That's for A. Okay, for part A. Find the ball's potential energy at this height. So, for that, we're just looking at what the energy is. The energy is mgh, a type of energy we're dealing with, potential energy. The equation is 1.8 times 10 times 0.75. Mass, g, and 0.75. So that is going to be there. Okay? And then part B asks us, Find the ball's velocity at its lowest point. So now it's back to being a story. We have this point here, and we have this point here. The total energy here is going to equal the total energy here. So we say initial energy equals final energy. Our initial energy is all Eg, which we just found to be 13.5. Our final energy, though, we asked the question, what kind of energy is it? Is it high at this point? No. Is it fast at this point? Yes. Is it springy? No. So our final energy is just kinetic. So then we have our 13.5 Eg equals 1/2 mv squared. So our 13.5 equals 0.5 times 1.8 times v squared. Simplifying that down is 0.9 v squared. It's 15 equals v squared. So v equals 3.87. Okay. So now, Bob is jumping on his trampoline. Spring constant is that. Bob sinks down that far. How high above the trampoline will his jump take him? So for our picture, I have this fancy trampoline. Here's where he starts, right? He's stretching out the trampoline 0.8 meters, and then he shoots into the air, and you want to know how high he goes before he comes back down. Okay? If I paused it right here, then I can figure out how fast he's going at that point, because all his energy right here is kinetic. But it's not kinetic right here. Right here, it's gravitational, because he's high but not fast anymore. Right? Remember we talked about how you toss a ball into the air, and at the tip of its path, the top of its path, it stops moving for an instant and then comes back down. So that's where we're at right now. We're at the top of the path. Okay, the tip top. Okay, so knowns and unknowns. Mass is 60. Spring constant is 3,500. Distance the spring stretches, or the trampoline stretches, is 0.8. Height is our question mark. So initial energy equals final energy. Our initial energy, again, he's not high, he's not fast, but he is springy. He's not fast or springy, but he is high. So that's why it's ES equals EG. So our equation for ES is 1/2 kx squared. Our equation for EG is mgh. So 1/2 k is 3,500. X squared is 0.8 squared. M is 60. G is 10. H is h. So simplifying that, we get 1120 equals 600h. So dividing both sides by 600, we get that our final height is 1.87 meters. Okay. So again, to recap, whenever you're telling a story of like a before and after, then we're going to go with E initial equals E final, where that's our energy at the beginning of the story, and that's our energy later on in the story, right? And then we just figure out what type of energy we have at this point and what type of energy we have at this point. And we stick them in the equations, substitute, and solve. Good luck.